Good morning, everyone. I am Dr. Anushya, Assistant Professor of Mathematics. In this video, I am going to teach Lagrange's method. So, first, we are going to derive Lagrange's interpolation formula for unequal intervals. First, we consider the set of arguments x and the corresponding entry y. We denote the n arguments as x0, x1, x2 up to xn and each corresponding y as y0, y1, y2 up to yn. First, we take a polynomial f of x as f of x equal to a0 x minus x1 x minus x2 up to x minus xn plus a1 into x minus x0 x minus x2 up to x minus xn plus and so on plus an into x minus x0 x minus x1 up to x minus xn minus 1. Now our aim is going to find the constant a0 a1 up to an. In order to find this, we are going to substitute the each value x0, x1, x2, xn in equation 1. So first we are going to substitute x0 in the equation 1. We get y of x0, that is y0, equal to a0 into x0 minus x1, x0 minus x2 up to x0 minus xn. Because let's see this equation 1, except the first term, all other terms have the term x minus x0. So if we substitute x equal to x0, all other terms will be equal to 0 except the first term. So we have only the first term if we substitute x0 equal to x0. So a0 equal to y0 divided by x0 minus x1, x0 minus x2 up to x0 minus xn. Similarly, we can find y1. Here we substitute x equal to x1. So we get a1 equal to y1 divided by x1 minus x0, x1 minus x2, x1 minus xn. In general, an equal to yn divided by x1 xn minus x0, xn minus x1 up to xn minus xn minus 1. Now we substitute all these constant a0, a1 up to an in equation 1. We get y equal to x minus x1, x minus x2 up to x minus xn divided by x0 minus x1, x0 minus x2 up to x0 minus xn into y0 plus x minus x0, x minus x2 up to x minus xn divided by x1 minus x0, x1 minus x2 up to x1 minus xn into y1 plus and so on plus x minus x0, x minus x1 up to x minus xn minus 1 divided by xn minus x0, xn minus x1 up to xn minus xn minus 1. This equation is known as Lagrange's formula. Let's see a problem. Construct the polynomial for the following data using Lagrange's method. Hence evaluate f of 2.5 and f of 3.5. Here we have data x equal to 0, 1, 3, 4 and f of x equal to minus 12, 0, 6, 12. Here we note that the intervals, that is 0, 1, the difference is 1 and the difference between 1 and 3 is 2 and the difference between 3 and 4 is 1. So the difference are unequal. So here we use Lagrange's method. Now we come to the solution. First we denote all the x and f of x as x0, x1, x2, x3, y0, y1, y2, y3. Here we have 4 entries x0, x1, x2, x3 and to each entry we have a corresponding y y0, y1, y2, y3. We know the Lagrange's formula for n terms. Here we have only 4 terms x0, x1, x2, x3. So we use the first 4 terms of the Lagrange's formula. Y equal to f of x equal to x minus x1 into x minus x2 into x minus x3 divided by x0 minus x1 into x0 minus x2 into x0 minus x3 into y0 plus x minus x0 into x minus x2 into x minus x3 divided by x1 minus x0 into x1 minus x2 into x1 minus x3 y1 plus x minus x0 into x minus x1 into x minus x3 divided by x2 minus x0 into x2 minus x1 into x2 minus x3 into y2 plus x minus x0 into x minus x1 into x minus x2 divided by x3 minus x0 into x3 minus x1 into x3 minus x2 into y3. Now we are going to substitute x1, x2, x3 and y0, y1, y2, y3. The values, all the values are given. We substitute these values in this equation. We get the required Lagrange's polynomial. F of x equal to x cube minus 7x square plus 18x minus 12. This is the required Lagrange's polynomial. Now we are going to find the value of f of 2.5 and f of 3.5. We have the Lagrange's polynomial f of x. We substitute x equal to 2.5 in this equation. We can get the value of f of 2.5 which is equal to 4.8.75 and we substitute x equal to 3.5 in this equation. We get the value of f of 3.5 which is equal to 8.125. Let's see another problem. Find the equation of cubic curve that passes through the points minus 1 comma minus 8, 0 comma 3, 2 comma 1 and 3 comma 2 using Lagrange's interpolation formula. Now we denote this coordinate points as x0 and y0. First we denote minus 1 comma minus 8 as x0 and y0, 0 comma 3 as x1 comma y1 and 2 comma 1 is x2 comma y2 and 3 comma 2 as x3 comma y3. In this problem, there is no need to find any value of f of x. Only we have to go find the polynomial of the cubic curve. That is the Lagrange's equation for this given data. So first we write the Lagrange's formula for 4 terms. Since we have 4 terms only, we write the first 4 terms of the Lagrange's formula. Next, we are going to substitute x1 equal to 0, x2 equal to 2, x3 equal to 3 and y0 equal to minus 8, y1 equal to 3, y2 equal to 1 and y3 equal to 2. By simplifying these equation, we get 7 by 6 x cube minus 31 by 6 x square plus 14 by 3 x plus 3. This is the required Lagrange's equation. That is the equation of the cubic curve. In this video, we have seen how to derive the Lagrange's formula for unequal intervals and by using this formula we solve 2 problems. Thank you.